Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, 7th graders, happy Aloha Friday to you. It is almost the weekend. And first, my grandson Brayton, whose picture I showed you last week, I think, sometime, or this week actually, maybe the front of the week. Anyway, he has a big rugby match today, actually, which is Saturday, down in Australia. So the other team they're playing is very good and very big. So anyway, go Brayton. So anyway, first, 7th graders, I want to go over the test just really quick with you. And then I've got 3 additional things I want to do, and I have 2 guest speakers in today. So you'll need to use that white sheet. So while I'm starting to chat, on your white sheet, on one side you'll want to number to 10, and on the other side you will want to number to 10. It's going to be a chance to get 10 easy peasy points if you do your part. If you don't, it won't be 10. It'll be 9.5 or 9 or 8.5 or 8 or 7.5. That's 75%. Or 7. That's 70%. That's a C minus. Or 6.5. That's not a C. Anyway, do your part. Do a nice job on your bullet facts on your speakers. Okay, 7th graders, John 1:1, actually John 1:3. So through him, or I'll go with it through him. Through him all things were made, and without him nothing was made that has been made. Meaning Jesus made everything. Colossians 1:17 says that everything holds together by Jesus, nothing else holds together. That's one point. List the 4 layers of the earth from the outside in, starting with crust. So, and then mantle, outer core, inner core. 2 things that greatly increase the deeper you go into the earth. Heat and temperature, half a point each. 5 characteristics of minerals. I gave you naturally occurring, inorganic, unique crystals, unique chemicals, solids. Characteristic of minerals like hardness or luster or density, or examples of, and I gave you the letter P for properties of minerals. How tight the atoms are packed, density, number 13, 14, and 15. Rocks that are formed by dirt, sediment getting squeezed together are known as, I gave you S, sedimentary. One specific example, shale, limestone will work, sandstone. 16 and 17. Rocks that are so hot they become liquid. They're fire formed. That would be igneous, one example. Obsidian would be an example of pumice, another example of igneous. Rocks that change from one kind to another. So, you know what they are? Metamorphic, heated and squeezed. And then an example would be shale. I asked for a pair. So shale to slate, sandstone to marble. Limestone to marble. There's a couple. Melted rock underground, magma, come out of the ground, lava. Geology, scientific study of the earth. Almost done with page 1. Give one way we can hypothesize, one way why we can hypothesize what it's like inside the earth. Rocks that come out in liquid form and cool. So one way to tell us. Another way, seismic waves or earthquake waves. So there's a couple of ways. The Mohs scale is about hardness, and mineral number 10, diamond. Second page, 2 ways crystals form. They form by cooling. It's really CD, cooling and dissolving. Okay, kinds of rock salt, halite, purple quartz, amethyst. The mineral that gets dissolved by rain or running water, limestone caves. Very soft mineral, scratch with a fingernail. Talc, loaded with lead metal, very dense and shiny. Galena, that's a G, loaded with lead. Galena. Lots of copper. Chrysocolla, the C mineral, the mud rock shale. The mud rock can be metamorphosed into slate. The majority of the continental crust is made of basalt. So basalt at the bottom of the ocean. The writing mineral graphite, low density volcanic mineral that floats in water. Pumice, ordinary white mineral with crystals, the same shape and characteristics as its purple cousin, in quotes, just quartz. Quartz. Fool's gold is, it will come back to me in just a minute. So, looking over the list, sometimes things escape me. It's got lots of iron in it. Iron pyrite, fool's gold. Lots of this varied colored mineral in Arizona. Tiny sand grains, sandstone, black mica, black mica, biotite. Magnetic mineral loaded with iron magnetite. The majority of oceanic crust is made of this mineral. Did I do it twice? Basalt, that should have been continental. I may have done oceanic twice. Let me look. No, 34, sorry. The majority of the continental crust is granite. Some of you, your heart was fluttering. Sorry. Continental crust, granite. Oceanic crust, basalt. 43, a black mineral used to be plant material. Anthracite, it's a kind of coal. Very hard and dense black volcanic glass, obsidian. Beautiful white mineral, often used as a building stone. Marble. What historic event formed most of the sedimentary rock and a lot of the metamorphic rock? The GGF, the Great Global Flood. So anyway, there's your test, 7th graders. So, okay, get ready to use your white sheet. So get ready to use it. So, and then I've got a couple of guests to come in. So anyway, excuse me, this is a little intro on proteins, and you're going to get, the guest speakers are going to talk about proteins. Proteins are complex chemicals that do thousands of different jobs in your body. So, and you could do a bullet factor too from this if you wanted to. So, complex chemical molecules do thousands of jobs in your body. They do different jobs or functions. You've got about 20,000 different proteins in your body, and a total of anywhere from 80,000 to 400,000 proteins. Why don't we know the exact amount? It's so complex. It's just hard to figure it out. We can estimate. And proteins are made of 20, count them, 10, 20 different amino acids. Well, how can you get all of those different ones, 20,000? Well, the order, just the order of the amino acids. And get this, the shortest amino acid chain is 234 amino acids. And that protein has to have just the right number of amino acids in just the right place with just the right folding. The longest protein that we know of in the body is made of 34,000 amino acids. So the building blocks of proteins, amino acids. So, and you've got 20 different ones, but you can have varying number, varying order, and varying folds, all determine the exact thing that a protein does. So, anyway, your guests that are going to come in a minute are, first of all, Hank is going to come in, and he's going to talk about proteins and what they do, and then Dr. Stephen Meyer, who pulls his brains behind him in a wagon, in fact 2 wagons, he's so smart. That's a figure of speech. It means your brain is so big your head can't hold it. It's just a comparison. He's just really smart. Brain size doesn't determine mostly your intelligence. So anyway, Dr. Stephen Meyer is going to come in, And he's going to use pop beads, and he's going to talk a little bit about the probability of just one protein forming by materialistic causes. That just means matter doing it in a random way, with no one or nothing doing it. It just is random, accidental. In other words, Dr. Meyer is going to talk about the chance. It's going to be a fraction, 1 over 10, and it's going to be an exponent, and it's going to blow you away. And then he's going to give a quote at the end, Dr. Meyer. And the quote is going to say something about no reasoning scientist believes that proteins formed by chance. No, scientists don't believe that. It's just too improbable. So anyway, look for him saying that. Now I want to give you an example of this. And then, I've talked to you about mutations and how mutations are bad, right? Well, here's proof. Look at this. Now, I've got to make this come up right. There we go. Okay. These are red blood cells. Those are red blood cells. The bluish ones, there's what, 2 there, are white blood cells. But those are red blood cells, mostly normal. Now, they're made of 147, red blood cells are made of 147 amino acids. And they've got to be in just the right order with just the right folding. And if you substitute, if you get a mutation, and that mutation does this, it causes a red blood cell just with one change in an amino acid. One amino acid, a different amino acid than should be there, in the wrong place, substituting for a normal one. Do you see some of those red blood cells that are not round? They're not roundish? Like, I'll put the cursor on one. You see where the cursor is? Maybe not. Do you see it? You might not. But do you see some of those red blood cells that are this shape? They don't work right. They don't float through the bloodstream properly in the capillaries, and they can cause a tremendous amount of pain and even death. Just one amino acid out of place, and it causes the wrong chemistry of the red blood cell, so it's not correct, and it doesn't grab oxygen properly. So some of you have heard of sickle cell anemia. That's this blood disorder caused by a mutation. Remember, mutations are bad. Mutations don't make change, they get rid of change. Natural selection. But a mutation is a harmful or even fatal, and it can both cases with these red blood cells. So anyway, pretty good example, I think you would agree. So anyway, I'm going to have Hank come in, and Hank is going to tell you about proteins in your body, and he's going to explain protein drinks and protein supplements a little bit. And those of you, maybe you guys who are lifting weights, and you gals. So I shouldn't sell you short either. He's going to tell you why those protein drinks or protein supplements, maybe, you're wasting your money. He's going to explain. Okay? So anyway, and then Dr. Meyer's going to come in with his video. On one side, you're going to write neat bullet facts, neat complete bullet facts on one side, on Hank's video, and then Dr. Meyer's on the other. Do a neat job, neat complete, worth 10 points. If there's a super job done, I might even make it worth 12 points for a select few. Anyway, let's move Hank in, and we'll let Hank do his video, and then Dr. Meyer. So